All right, I want to go ahead and make sure that we're describing this object getting through the honors homework and making sure we feel comfortable with what we did. So it says describe the motion of the object model in the graph as the object speeding up or slowing down. I can't help it. I made this a trick question. And I also just randomly rotated this piece of PDF file. I don't know why I did that. Silly me. So let's go ahead and actually take a look here. So what we're looking at is the object. So the object is moving forward from the 15-meter mark at a steady speed. So this is a trick question. It is neither speeding up nor slowing down. And is in fact moving at a steady speed. Now, to get the object's average velocity, we're going to simply do a slope calculation. So let's be really careful here. For me, looking at this object, I would take the rise over the run, and in this case, I noticed that at 3.5 seconds, I'm at 50. So let me actually label this coordinate here just to be careful. So at 3.5 seconds, I'm at 50 meters, and I will actually do a similar labeling down here where I'm at the 0-second time, meaning I've just turned my stopwatch on and the car is just starting to move, and I'm at 15 meters here. So don't know what happened to my first little label here. Let me just put that back there. So this is again 3.5 seconds, and I'm at 50 meters. And now we can go ahead and actually calculate the rise over the run, which will be, again, when we calculate it, 50 minus 15, that's the rise part of the calculation, divided by the run part, which is going to be 3.5 minus 0. And so this ends up being 35 over 3.5. So I'm actually getting a speed of 10 meters per second, which is a very nice number, honestly, to end up getting for a speed. Now we write the mathematical model that describes the object's motion. Now for us, excuse me, so we're going to use the slope-intercept form. So we would simply write y is 10 times x plus, and the initial position is 15. I'm just going to give you a preview. In class, we're going to be using a different sign convention, or not sign convention, a different way of writing letters. So we're going to actually describe our position using the letter x. 10 will still remain 10 because it's a number. But instead of using x, since the x letter is actually time, this is actually going to be the way we write it later on. Now it says assume the motion remains constant. Let's determine the object's position at 10 seconds. So we're going to use the equation here, and what we're going to do is we're going to actually put in 10 for the time, and when we work that out, we're going to end up getting 115 meters. That's actually how we do part D. I hope that this next part seems familiar. It was the Kahoot that we did, and so in case you're wondering, the cyclists do not start at the same point because B starts ahead as its initial position, which is the y-intercept, is higher on the axis. At 7 seconds, which cyclist is ahead? Well, we can look and we can see that at 7 seconds, A is actually ahead. Since this is 5 seconds, 2 seconds later, wherever that is on the graph, A is clearly ahead. So we can simply say A is ahead because its position is further, meaning higher up on the graph. All right. Which cyclist is traveling faster at 3 seconds? Well, the answer is cyclist A. And we know that because the slope of the position graph is the speed, and the steeper the slope, the faster the object goes. This object, A, has a steeper slope than object B's graph. There we go. Similarly, we can actually add to this and say never. A always has a steeper position graph than B. So it always goes faster. So what's actually happening at the intersections of lines A and B is that A passes B. And that's really what's going on there. Now, continuing, how does the motion of cyclist A in this graph compare to that of A in question 1? So what I would say is this. The speed is identical, meaning the steepness of the slope. But in the new graph, A goes in reverse. Now, what's nice is in this next question, absolutely identical. All right. For C, which cyclist has the greater speed? Again, it is still, in the new graph, still A, even though it is backwards. Its slope is steeper, so its speed is faster. What's happening at the intersections of lines A and B? Same thing as in the first graph. They are passing each other. And which cyclist has traveled furthest during the first 5 seconds? There, let's double check. It's not a question of who's ahead. We can actually say that A has traveled furthest. A has traveled further as it has moved, as its vertical coordinate, which is position, has moved further along the y-axis. If this explanation confuses you, just think of buggies and rulers. A slow buggy only moves a little on the ruler, like B, and a fast buggy moves a lot along the ruler, and that's like buggy. That's like bicycle A. There we go. So that is the solution to the homework set, and I hope it's helpful.